Now, how can we check if a sequence is convergent or not? Well, I'm going to leave you a little bit disappointed here, maybe not, but in telling you that we're not going to spend a lot of time looking at convergence criteria or how to find out if a sequence is convergent for sequences per se, but only for special kind of sequences which are called infinite series, which we're going to see first next time. But many of those criteria rely on one fact which is very simple to check about regular sequences, just general sequences. And the fact is as follows. First of all, let me tell you that a sequence is monotonic if it is only increasing, like for instance this sequence here would be monotonically increasing, or if it is only decreasing, like this sequence here is going to be monotonically decreasing. So monotonic means it goes up all the time or goes down all the time. And you may be saying, yeah, I know that. That's the same thing as for functions. Yeah, exactly. Except that for functions, we haven't really used this idea very much except to attach a label. Here we're going to be using this a little bit more. So, why is this important? Well, because the first convergent fact is the following. A sequence that is bounded and eventually monotonic is convergent. Okay? So, I'm not going to give a formal proof for that, but just think about it. So if we have this sequence on the left hand side, which is monotonically increasing and bounded, it's going to have an upper boundary. And therefore, now this sequence will have to go up, but it cannot cross that line. Well, at some point it will have to get closer and closer to something. It cannot go back down, it cannot cross that line. It's either going to reach the limit at that line or somewhere below that line. Similar idea on the right hand side. If the function is monotonically decreasing and it's bounded, it's going to be bounded below. It's going to have a lower boundary. And therefore, where can it go? I mean, it's going down all the time. It cannot go back up again, but it cannot cross that boundary. It's going to have to get closer and closer to something. Either the something being either that particular line that will therefore provide the limit, or maybe some line in between where we see the boundary now and where the sequence is. Therefore, if we have a sequence that we know to be bounded and we know to be monotonic, we know automatically that this is convergent. And that's all as far as we're going to go with just sequences. We're going to now, next time, we're going to focus on a very special kind of sequences that are going to be providing us with a lot of information and a lot of applications. And we're going to see how we can check whether that particular kind of sequence is convergent or not.